On the same afternoon that the sun hurled a wall of superheated plasma into space, the ground beneath Peru tore open. 8 hours and 15 minutes. That was the gap between the sun's most violent outburst in nearly 2 months and the moment a magnitude 6.7 earthquake ripped through the southern Andes. 8 hours and 15 minutes, almost to the second. And if you've been watching the sky and the ground this summer, you already know that this wasn't the first time the two seemed to move together. So the question that's been quietly building all year, the question that serious scientists have wrestled with, and mostly dismissed, and that millions of ordinary people keep whispering anyway, finally has to be asked out loud. Is our planet being shaken from 93 million miles away? Before we go any further, if you want the truth about what's happening to this planet, without the hype and without the fear-mongering, stay with me, because what I'm about to show you is stranger and more important than a simple yes or no. And if honest answers to big questions are what you're here for, subscribing now means you won't miss what comes next. Let's start with what actually happened, because the facts alone are dramatic enough that nobody needs to exaggerate them. On August 20th, 2026, at 1 o'clock in the afternoon local time, a powerful earthquake struck the mountains of southern Peru. The United States Geological Survey put it at magnitude 6.7, centered roughly 24 miles northwest of a small town called Ayacucho in the Ayacucho region high in the Andes. Peru's own seismic agency initially posted a higher number, magnitude 7.2, which is a difference that matters more than it might sound, and we'll come back to why. Well, what everyone agreed on was the depth. This quake happened deep, somewhere between 66 and 99 kilometers below the surface, depending on which measurement you trust, and that depth turned out to be a kind of mercy. Because here's the thing about a magnitude 6.7. On paper, that is a big earthquake. It releases something like 30 times more energy than a magnitude 5.7. And it's the kind of shaking that can flatten poorly built structures and kill thousands when it hits the wrong place. But this one didn't hit the wrong place. It struck a remote, sparsely populated stretch of the high Andes, and it struck deep, which meant the energy had to travel a long way up through solid rock before it reached anyone. The footage that surfaced online showed dust rising off the mountain slopes, rocks tumbling down the hillsides, the earth quite literally shaking itself loose. But there was no scene of urban devastation, no collapsed apartment blocks, no frantic search through rubble. For once, a major earthquake had struck and the human cost stayed low. And when you understand the year that Peru and the whole western edge of South America has been bracing for, you'll understand why that word mercy is exactly the right one. Now, why does the disagreement over the magnitude matter? Because it tells you something about how earthquakes are measured and why you should never take a single early number as gospel. When a quake happens, different agencies around the world calculate its size using different networks of instruments, different formulas, and different amounts of incoming data. Early estimates get revised constantly in the first hours as more seismic stations report in. A gap between a 6.7 and a 7.2 isn't someone being wrong. It's the messy reality of trying to measure a rupture dozens of miles underground in the first frantic minutes after it happens. And the difference is not trivial. A 7.2 releases roughly 5 times more energy than a 6.7. So which number you believe genuinely changes how you understand the event? For our purposes, we'll lean on the USGS figure, the 6.7, while acknowledging that the truth may sit somewhere in between. But this earthquake did not happen in isolation, and that is where the story gets genuinely gripping. Because 2026 has been, by almost any measure, an extraordinary year for the Ring of Fire. That's the vast horseshoe of geological violence that wraps around the Pacific Ocean, tracing the edges where the planet's tectonic plates grind, dive, and collide. Something like 90% of the world's earthquakes and most of its active volcanoes live along this arc, and this year it has been roaring. Let me walk you through it, because the sequence itself is what has so many people convinced that some hidden force is pulling the strings. Back in early June, a magnitude 7.8 earthquake struck the southern Philippines, unleashing a swarm of aftershocks, several of them powerful enough to be major quakes in their own right. Then, on June 24th, disaster. A pair of earthquakes measuring around magnitude 7.2 and 7.5 devastated parts of Venezuela. That one was not merciful. The destruction was severe, the death and injury toll heavy, one of the deadliest seismic events the region had seen in a long time. And here is the detail that started turning heads. At almost the same moment, within roughly 30 minutes, a magnitude 6.9 earthquake struck Japan on the complete opposite side of the world. From there, it seemed to spread. A powerful quake struck Mexico, followed by extraordinary reports of unusual electrical activity in the sky, the Fuego volcano erupting, and a hurricane named Genevieve, exploding into existence off the Pacific coast and rapidly intensifying into a monstrous storm. Then Colombia was hit by a magnitude 7.4, then Indonesia, a magnitude 7.7. Then, on August 15th, another magnitude 6.9 struck near Medan in northern Sumatra. Japan kept rumbling almost monthly, with a magnitude 7.1 on July 28th by the Japanese scale. And now, Peru, Venezuela, Mexico, Colombia, Indonesia, the Philippines, Japan, and Peru, all within a matter of weeks, many of them deadly, many of them destructive. If you laid these events out on a 90-day timeline of global seismic energy, you would see a genuine burst, a period where the planet's largest earthquakes clustered together far more tightly than the quieter stretches before them. So let me ask you directly, because I genuinely want to know what you think, and this is the moment to tell me. When you see a run of major earthquakes like this, back to back to back across the globe, does your gut tell you it's pure coincidence, or does it feel like something is connecting them? Drop your honest answer in the comments, because the tension between those two instincts is exactly what the rest of this video is about. Here is where I have to be very careful with you, and very honest, because this is where a lot of the internet goes off the rails. There is an idea, popular in certain corners, that these earthquakes are linked by geometry. The claim goes like this. When a large quake strikes one point on Earth, another tends to follow at the antipode, the exact opposite point on the globe, as if the shock waves travel through the planet and converge on the far side. People will point out that the antipode of that Sumatra quake sits near Ecuador in Peru, and that a Peruvian quake did indeed follow. Ping-pong, back and forth, one side then the other. It's a seductive idea. It feels like a pattern, and I understand completely why it grabs people. But I owe you the truth, and the truth is that mainstream seismology does not support it. The USGS and researchers around the world have examined the question of whether distant earthquakes trigger one another. And while there is real, measurable evidence that the seismic waves from a very large quake, a magnitude 8 or above, can momentarily nudge faults on the other side of the planet, this is a subtle statistical effect, not a reliable one-for-one trigger. It does not produce a dependable ping-pong of one major quake, answering another at the antipode. Here's the deeper problem. The Earth has around 100 to 150 magnitude 6 or greater earthquakes every single year, and they overwhelmingly happen along the same active plate boundaries, many of which sit roughly opposite other active boundaries, simply because tectonic zones are spread around the globe. So if you go looking for a quake near the antipode of another, you will very often find one, not because they're connected, but because the planet is constantly shaking in all these places anyway, when almost any point you pick has an active fault somewhere near its opposite. The antipode had a quake too, stops being a prophecy and starts being a near certainty. That's what makes these patterns so convincing and so misleading at the same time. Our brains are pattern detection machines. We evolved to spot the tiger in the grass, to notice the connection, to find meaning in the noise. It kept our ancestors alive. But that same gift betrays us when the pattern isn't really there, when we're looking at randomness and our minds insist on drawing a line through it. A forecast that says a large, chronically active subduction zone, one of the most earthquake-prone stretches of coastline on the entire planet, will experience a magnitude 6.5 or greater quake sometime soon is not really a bold prediction. Western South America produces earthquakes of that size regularly. Saying it will happen there eventually is a bit like forecasting rain in a rainforest. When it comes true, it feels like a triumph, but the base rate was against you being wrong. I'm not saying this to be a killjoy, and I'm certainly not saying the sun and the earth have nothing to do with one another. I'm saying it because you deserve to understand the difference between a genuine scientific finding and a compelling coincidence dressed up as one. And believe me, the real science here is every bit as fascinating. So let's talk about the sun, because on August 20th, the sun was in fact putting on a show. After nearly 2 months of relative quiet, a new sunspot region, cataloged as 4513, rotated into view and began growing fast as it turned toward Earth. In just 24 hours, it fired off 4 M-class solar flares, the middle tier of the flare classification system, with the strongest reaching what was described as an M8.1. These were the first M-class flares of the entire month of August, and the strongest solar activity in around 7 weeks. One of those flares also launched a coronal mass ejection, a colossal cloud of magnetized plasma blasted out from the sun's surface. And crucially, this eruption came from the edge, the limb, of the sun, meaning it was not aimed at Earth. NASA's space weather models confirmed it. The plasma cloud was sweeping off to the side, not toward us, with perhaps only a minor density enhancement grazing our planet's neighborhood. Now, let me define these terms simply because they matter. A solar flare is a sudden intense flash of radiation, an explosion of light and X-rays that erupts when the sun's twisted magnetic fields snap and reconnect. Because it's made of light, its radiation reaches us in about 8 minutes, and it can charge up the upper layer of our atmosphere, the ionosphere, and disrupt radio communications. A coronal mass ejection is different. It's actual matter, billions of tons of plasma, and it travels slower, taking 1 to 3 days to cross the gulf between the sun and Earth, and only causes geomagnetic storms if it's aimed our way. On August 20th, We got the flash of light, but the cloud of matter missed us. Here's what else was happening in near-Earth space at that moment, because the setup was unusually busy. Our planet had just been passing through what's called a coronal hole high-speed stream, a gush of fast solar wind pouring out of a gap in the sun's atmosphere. That stream had pushed solar wind speeds up towards 600 kilometers per second and triggered several hours of minor G1 level geomagnetic storming, the gentlest category of space weather storm. So on that single day, you had elevated solar wind, a lingering geomagnetic disturbance, a fresh burst of solar flares charging the ionosphere, and a major earthquake in Peru, all layered on top of the ongoing global run of large quakes. It is, I'll admit, a lot of things happening at once. And when a lot of dramatic things happen at once, the pull to connect them into a single story becomes almost irresistible. So does the science support a connection between solar activity and earthquakes? This is where I want to give you the honest, careful, up-to-date answer, because it's more interesting than either extreme. The overwhelming consensus among seismologists and space weather scientists is that there is no established, reliable causal link between solar flares and earthquakes. The USGS states plainly that earthquakes are driven by the slow, relentless motion of tectonic plates and the stress that builds along faults over years, decades, and centuries, and that this process is not controlled by the sun. The energy involved in a large earthquake is generated deep within the Earth's crust, and the mechanism has nothing to do with a burst of light from 93 million miles away. But, and this is the part that keeps the door open just a crack, there have been serious researchers who've looked for subtle statistical correlations. A few studies over the years have reported weak associations between certain kinds of solar activity and earthquake occurrence, proposing exotic mechanisms involving electric currents in the ground or changes in the Earth's magnetic environment. These studies exist, they are real, but they remain contested, unreplicated in any robust way, and far from accepted. For every study claiming a hint of a signal, others find nothing when the numbers are examined rigorously and the base rates are properly accounted for. The scientific verdict, as it stands today, is that no such link has been demonstrated, and the burden of proof sits squarely on anyone claiming otherwise. And this brings us to the trap that catches so many people, the 8-hour and 15-minute coincidence we started with. When you experience a big solar flare and then a big earthquake on the same day, the connection feels overwhelming. But remember what I told you. The Earth has a magnitude 6 or larger earthquake somewhere on its surface every few days on average, sometimes multiple in a single day. The Sun, during an active phase of its 11-year cycle, can produce flares regularly too. When you have two independent events that each happen fairly often, they will inevitably coincide sometimes, purely by chance. The flare didn't cause the quake any more than the quake caused the flare. They were two separate expressions of two separate systems, and our minds, hungry for meaning, stitched them into a single narrative. I want you to sit with that for a second, because it's genuinely one of the most important lessons you can carry out of this video and into the rest of your life. The universe produces coincidences constantly, and the more events you track, the more coincidences you'll find. The skill, the real skill, is learning to feel the pull of the pattern while still asking whether the pattern is really there. That's not cynicism, that's clarity. And clarity is what keeps you safe and sane in a world absolutely flooded with confident-sounding predictions. So if the sun isn't shaking Peru, what is? The answer is both simpler and far more powerful, and it's happening right now beneath that coastline, whether the sun flares or not. Western South America sits above one of the most formidable geological engines on the planet. Off the coast of Peru and Chile, the Nazca Plate, a slab of oceanic crust, is diving beneath the South American plate at a rate of several centimeters per year. That's the subduction zone, and it is the single most productive source of giant earthquakes on Earth. This is the same fault system that, in 1960, produced the largest earthquake ever recorded by instruments, the magnitude 9.5 that struck Chile. This zone has generated magnitude 8s and 9s throughout recorded history, and it will do so again. Not because of the sun, because a continent-sized slab of rock is being forced into the planet's interior, storing up unimaginable stress until it fails. And here's a sobering detail that has nothing to do with space weather and everything to do with geology. That deep magnitude, 6.7 near Ayacucho, carries a small but real possibility of being a foreshock, a warning tremor before something larger. Historically, roughly 5% of earthquakes are followed by an even bigger one nearby within days. This particular stretch of the subduction zone has a distinctive bend or kink in its geometry, a place where the descending slab doesn't slide as smoothly, which some suggest means it could require an especially massive rupture to fully release the accumulated strain that, in parts of this region, has been quietly building for a very long time. So the honest reason to keep watching Peru isn't the sun, it's the plate boundary. That's where the danger genuinely lives, and that's what preparedness should actually focus on. This is the crucial distinction, and I'd argue it's the whole point. If you believe earthquakes are triggered by solar flares, you might think you can predict them by watching the sun, and you might feel a false sense of control, and you might let your genuine physical preparedness slide because you think you'll get a warning. But the truth is that nobody, no scientist, no agency, no forecaster anywhere on Earth can currently predict the specific time, place, and size of an earthquake with any reliability. What scientists can do is calculate long-term probabilities, identify which regions are dangerous, and tell you with confidence that if you live near an active fault, you should be ready. Chasing a solar prediction that doesn't work could actually make you less safe, and that's why getting this right matters far beyond satisfying our curiosity. Let me widen the lens for a moment, because there's a bigger picture worth understanding, and it's real. We are living through a period of genuinely heightened awareness of Earth's volatility, and some of that is not imagined. The oceans have been running warmer, and 2026 has been shaping up as a strong El Niño year, a climate pattern that redistributes heat across the Pacific and supercharges certain weather systems. That's why the Pacific has been churning with powerful cyclones this season, including the hurricane that battered Hawaii's Big Island, spiking to major intensity and leaving real destruction in its wake, while the Atlantic stayed comparatively quiet. Warmer seas, more energetic storms, a more volatile atmosphere. These are measurable, documented trends, and they are worth taking seriously on their own terms. But notice what I'm doing here. I'm separating the things that are genuinely connected from the things that merely appear connected. El Niño and Pacific cyclones, real, physical, well-understood link. Warming oceans and more volatile weather, solid science. Solar flares and antipodal earthquake ping-pong, not supported by the evidence. The discipline of keeping those categories separate is what turns a fire hose of scary headlines into actual understanding. And understanding, not fear, is what you need. Because here's the truth about fear. It makes you feel like you're doing something while actually paralyzing you. Understanding does the opposite. It's quiet, it's steady, and it moves you to take the concrete steps that genuinely protect you and the people you love. So let's talk about those steps, because this is the payoff, the thing you can actually walk away and act on. The lesson of 2026's roaring ring of fire is not that the sun is coming for us. It's that large earthquakes are a permanent feature of life for a huge fraction of humanity, and that they strike with little or no warning. Whether you're in Peru or Japan or Indonesia or along the fault zones of the western United States, from California up through the Pacific Northwest, the responsible response is the same. Know whether you live in a seismically active region, and most people near the ring of fire do. Secure the heavy objects in your home that could fall during shaking. Keep a stock of water, food, and essential supplies that could carry you through the chaotic first days after a major event when help may not arrive immediately. Have a plan for how your family will find each other. And crucially, learn what to actually do when the ground moves, because those first seconds matter enormously. This is the strange gift buried inside a year like this one. All these distant disasters, all this shaking on the far side of the world, can serve as a reminder to look at your own situation clearly and honestly. Not to live in dread, waiting for the sky or the ground to betray you, but to prepare calmly and then get on with your life. Preparedness is precisely what lets you stop worrying. Once your supplies are ready and your plan is set, you've done the hard part, and you can release the anxiety because you've traded fear for readiness. I want to return, before we close, to that opening image, because now you can see it clearly for what it is. A violent flare erupting from the sun, and 8 hours later the Andes shaking. Two of the most powerful forces in our corner of the cosmos seeming to move in unison. It is a genuinely awe-inspiring thing to contemplate, the sun and the earth, the sky and the ground, all part of one vast, interconnected system. And there's nothing wrong with feeling that awe. The mistake is only in letting the awe outrun the evidence, in taking a breathtaking coincidence and declaring it a law of nature. The universe is connected in countless real and beautiful ways, from the tug of the moon on our tides to the sun's radiation shaping our atmosphere. The honest work, the work worth doing, is figuring out which connections are real, how strong they are, and which are simply the beautiful accidents of a busy cosmos. The earthquake in Peru was real. The suffering across Venezuela and the other struck regions this year was real, and those people deserve our attention and our compassion, not our theories. The solar flares were real. The strong El Niño and the raging Pacific cyclones are real. The Ring of Fire is real, and it is, right now, more active in our awareness than it has been in a long time. But the story that ties them all to a single hidden cause, that story is one our pattern-hungry minds tell us, not one the evidence supports. And knowing the difference doesn't make the world less wondrous. It makes you harder to fool, and it makes your wonder worth something. So the next time you see a headline pairing a solar flare with an earthquake, or a confident forecast that the next big one is coming to a specific place because the geometry demands it, I hope you'll remember this. Ask about the base rate. Ask how often each thing happens on its own. Ask whether the prediction was specific enough to have failed. And ask whether the mechanism is understood or merely asserted. Those 4 questions will protect you from 99% of the confident nonsense the internet will ever throw at you about earthquakes and about almost everything else. Our planet is a restless, living thing, powered by heat from its own deep interior and bathed constantly in energy from a star that never stops burning. It shakes, it erupts, it storms, and it always will. Understanding that, truly understanding it, is not frightening. It's grounding. It puts you in an honest relationship with the world you actually live on, rather than a fearful relationship with the world some algorithm wants you to imagine. And from that grounded place, you can do the one thing that genuinely matters. You can be ready, and then you can live. That's the real story beneath the shaking, and I hope it leaves you a little more clear-eyed than when we started, because a clear head is the best survival tool you will ever own. If this way of looking at the world resonated with you, if you want the events shaking our planet explained honestly, without the fear and without the fairy tales, then subscribe to W for weather. Hit that like button so more people find their way to the truth, and tell me in the comments what surprised you most today. I read them, I learned from them, and your questions shape what I cover next. Until then, take care of yourself, prepare wisely, and keep looking up and down with clear eyes. I'll see you in the next one.